We are now going to talk about simplifying expressions of the forms a raised to the 1 divided by n, and also a raised to the m divided by n. This will continue our discussion where n for b raised to the nth power is a rational number. Remember, a rational number is a fraction composed of an integer divided by an integer. So let's look at our definition of a raised to the 1 over n and a raised to the m over n. So we're going to let m and n be integers such that m divided by n is a rational number in lowest terms, and we're going to let n be greater than 1. We're going to let n be positive. So this means that a raised to the 1 divided by n is equal to the nth root of a. So very important, that means that the denominator of our fraction indicates the root or index of our radical. So n is our root, our index. Similarly, if we have a raised to the m over n is still our root. So notice, we have n right there, but a is raised to the mth power. So m is equal to our power. And notice there's another way we can write this. We can either write it so that m is the power of a underneath the radical, or you can choose to write the power of m outside your radical. And this is going to be very important in terms of using this definition throughout our time on this video. So if n is even, if the root is even, then a, the base, must be greater than or equal to 0. If a is negative, then this is not going to be a real number. By understanding the definition of a raised to the 1 over n and a raised to the m over n, we can convert expressions from radical notation to exponential, and then vice versa from exponential notation to radical. So we want to notice here, our root is 3 and our power is 5. So a good phrase to remember so that we can convert from radical to exponential is power over root. So the root is always our denominator and the power is our numerator. So this is m raised to the, and we need to figure out what goes in the numerator, what goes into the denominator to convert from radical notation to exponential. So 5 is our power. I'm going to just put a p there. And 3 is our root. So this is equivalent to m raised to the 5 over 3. Now for our next example, notice our power is 1 and our root is 2. And a root of 2 is not usually written this way. And the reason for this is the 2 is implied. And so we simply write the square root symbol. So anytime there is not a small number in this area right here, that means that it is the square root. So this is implied. It's not needed to be written. So it is implied to be 2. So we just write the square root of a. Your question, you're going to convert the 4th root of a raised to the 7th power to exponential notation. And second question, you're going to convert 8 raised to the 1/3, and you are going to simplify. Next example. We need to understand what 8 divided by 27 all raised to the 2/3 actually means. So 2 again is in our numerator, so that is the power. And 3 is in our denominator for our fractional exponent, so that is the root. So this means the cubed root of 8 divided by 27. Now the power is 2, so I have 2 choices of where to place this 2. I can put it inside my radical, or I can put it outside my radical. And I'm going to put an asterisk next to this. This is what I was talking about up above. If you think about this first form, I know that 8 squared is 64. But without a calculator, I do not know what 27 squared is. And then if I don't know what 27 squared is, I certainly can't figure out what the cubed root of this is. So if I attack this problem in this way, I am simplifying this by first addressing the root. So we're going to do this first, and then address the power. So cubed root of this fraction, cubed root of 8 is 2, and that is because 2 raised to the 3rd power is 8. The cubed root of 27 is 3, and that is because 3 raised to the 3rd power is 27. And now I can address the power. So 2 over 3, quantity squared, is equal to 2 squared, which is 4, over 3 squared, which is 9. So your job is to now convert 16 raised to the 3/4 to radical notation and simplify. Now let's turn our attention to negatives. And so if you look at problems 4, 5, 6, and 7, they're almost all the same, but there are some major differences for each of the problems. So for our first one, we want to recognize that this is read as the negative of 4 raised to the 3/2. Notice that the negative is not part of our base. The base is 4, and only 4 is being raised to the 3/2. So this is equal to the negative of 4 raised to the 3/2. Now our power is 3, and our root is 2. So this is equal to the negative of the square root of 4. And because the power is 3, I'm going to make my life easier by putting that 3 on the outside. I'm going to simplify with my radical first. So the square root of 4 is 2. And this negative just happens to come along for the ride. So it's negative of 2. We still have to cube it. So again, the negative goes along for the ride. It is out front. And so this is the negative of 2 cubed, and 2 cubed is equal to 8. So our answer is negative 8. For problem number 5, notice now that the base is negative 4 because we have our parentheses surrounding both the negative and the 4. So our power is 3, our root is 2. And so this is equal to the square root of negative 4 cubed. Now, not only is our root 2, our root is even. And remember from the front page, if our root is even, then the base must be positive. But our base is negative, which means this is not a real number. And so we're done there. Problem number 6. Now the negative is not part of the base. It is not a coefficient. The negative is now part of our exponent. So if we remember, if we have a negative exponent, that means we're going to take the base and move it from the numerator to the denominator. So we have a negative exponent, so we're going to move the base. Our base is 4. From the numerator to the denominator. And so that means that leaves us with a 1 for the numerator, because I have to create a denominator. Now be careful here. The negative means we need to move the base of 4 to the denominator, but we do not do anything with the exponent. It simply becomes positive. And now we have a power of 3 and a root of 2. So this is 1 over the square root of 4 cubed, which is 1 over 2 cubed, which is 1 over 8. And then lastly, the only difference between 6 and 7 is there is a negative out front. So this is equal to the negative of, now we have a negative exponent, so I'm going to treat this the same way. This is 1 over 4, now raised to the 3/2. And do you notice that this is exactly the same as what we have right here? And so the negative is out front. This is negative 1 over the square root of 4 cubed. This is the negative of 1 over 2 cubed. This is the negative of 1 over 8. And notice again, the negative was out front. It is not part of our base, and therefore the negative trails. You have 2 more questions. You are asked to convert the negative of 64 raised to the 2/3 to radical notation and simplify. And now you are asked to convert negative 64. So the base is negative 64 raised to the 2/3 and simplify.